Okay, so we're going to deal part two. I'm going to do some of the questions that I did not do in the first video. And these two are a version of a state test question that came out last year and that I'm not too fond of. I just don't think it's a good question. But nevertheless, we're going to have to do it. So here's Mark setting up a tent. So hopefully I can explain it. Well, tent. So if you go camping, there's your tent, right? There's your tent on the ground. There's a zipper, and then the tent is tied with little, so it doesn't fly away, right? These things, and you probably need a few of these around, right? The tent itself. So, Mark's setting up a tent during a camping trip. The tent came with 8 feet of rope. So you have 8 feet of rope. So imagine you have this long stretch of rope that you're going to use for these pieces, right? To hold the tent down and as well as to tie the tarp on top of the tent. So I don't know what that means, but there's a rope, and I'm going to use a different color. So a part of the rope will be used on top to tie the tent. Okay, so imagine you have this piece of rope, and it's 8 feet. So the first thing he does is he takes 28.5 inches. So I'm just gonna, again, this is obviously not scale. So he's going to weigh 28.5 inches of this for this top part. Okay. And then the leftover, and I'll try, what color? The leftover, he wants to cut into 7.5 inch sections. So I'll make little cuts like this. Okay, 7.5 inch sections. Now, the question is, how many 7.5 inch sections can there be of this the smaller pieces can we have? So it says write and solve an equation to determine the number of 7.5 inch sections of the rope that Mark can cut. So how many of these little smaller pieces will he be able to cut? So but the first thing you have to realize is that this whole string here is 8 feet. We have to change that to inches. Remember that 1 foot has 12 inches, so 8 feet has 8 times 12. This is 96 inches. So right off the bat, I would go like this, and I would sort of cross this out, so I don't even have to deal with feet anymore. So what I do know is that if I want to write an equation, I can write it like this. So what do we know equals 96 inches? So the total string available is 96 inches. So I know that this blue piece over here plus several of this 7.5 inch pieces will give you 96 inches. So let's write that as an equation. So in green, 7.5, and I'm going to change that to a decimal, 7.5 times sections or inch sections. I don't know what letter to use. 7.5 inch sections. I don't like to use the letter S. Well, let's use the letter. So how many 7.5? And hopefully you can tell that this is an S. 7.5 sections. How many 7.5 sections? So 7.5 times the number of sections that I can cut, however many there are, plus this section here, which is 28.5 that he used, the 28.5 inches that he used in the beginning, will give us a total of 96. Okay, so we can definitely solve the equation now. It's minus 28.5. On this side, minus 28.5, and I have no idea what my calculator is, but we'll go along. So I have 7.5 S. Okay, I'll just write that S. This cross out becomes 0, equals 0. 15 minus 8 is 7. No, sorry. 28.5. So if I subtract, I'm going to get a 5. 15 minus 8 is going to be a 7, and 8 minus 2 is going to be a 6. I'm going to have 67.5, which I'm then going to divide this by 7.5 and divide by 7.5. Alexa, what's 67.5? And Alexa's not listening to me. Okay, so let's use our dear iPhone, and we have 67.5 inches divided by 7.5. So we can have, so the number of sections, okay, so this is going to become 1, and the number of sections, 7.5 sections that he can have is 9. So he can actually have 9 of these. So there's 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, and obviously I just made this too long, my initial drawing. Okay, so that's how many he would have. So imagine, so it sort of makes sense, right? He had a long piece of rope. Okay, it's a long piece of rope, and I'll sort of try to explain again. A long piece of rope that was 96 inches, right? Sorry, 8 feet, which we changed to inches. So he had a long piece of rope, and he cut 28.5 inches. So he used, I'm not going to say that he used, put it in blue, he used this section to tie the top part of this tent. And then the remaining part he cut into 7.5 inch sections, right? Sections like this. So how many of these little smaller strings was he able to make? And that's how I made the equation. You know, it's not that bad. I didn't like it when I first read it. So now let's just, we're doing it again. So I get to explain it a third time. So baby Mark is sending a tent, and then his tent is a little bit smaller because he's a little bit younger and tinier. So here's a tent again. Okay, here's a tent on the ground. And it comes as 5 feet to rope. So here's a rope that's 5 feet. And he needs to use 23.25 inches of the rope to tie. So he's going to tie, and I'm going to use black here. So I don't know where he's tying. So using this piece of string, which measures 23.5 to tie it somewhere. Okay, inches. So from his initial 5 feet of rope, and the 5 feet of rope is the same thing as 60 inches, right? He's going to take this much, and I'll try to, it's best, this much, take this much, and use it to tie the top of the tent, maybe to a tree or something. I have no idea. So now, and then the leftover, which is this area right here, he wants to cut it into 5 1/4 sections. So he wants to cut it into 5 1 sections. So here is a section that measures 5 1/4 inches. Then he wants to cut another section that measures 5 1/4 inches. Another section that measures 5 1/4 inches, and so forth and so forth. So out of the remaining leftover string, after he cuts the initial 23.5 inches away, how many 5 1/4 can he cut? So the equation will probably look like this. So you have a string that measures 60 inches, right, from here to here, and the string is going to be made up of smaller parts. So it's going to have 5 1/4, and I'm going to write that as a decimal. Or you can leave it as a fraction. It's up to you. 5.25 pieces. Okay, smaller pieces. It's going to, so this 60 inches is going to be 525 times however many pieces we can get out of it, plus this longer part, which is 23.5. Please understand the problem. I will go over it on Monday again, but if you have a head start on understanding it, it makes life much easier. So minus 23.5 on both sides, and on this side I get the 5, 9 minus 3 is 6, 5 minus 2 is 4, 46.5, and 525p, divide both sides by 525, and the number of the pieces of little string that measure 5 1/4, it's going to be, I have no idea, 46.5 divided by 5.25. And it says here that I can make 8 unless my calculation is wrong, 8.85, 71, blah, blah, blah. So it's a decimal that goes on, and I'm just going to round it to 8.6. So the maximum number of these little strings that measure 5 1/4 that I can take is going to be 8, because I don't have enough to make the ninth one. Okay. So that's that. It wasn't that bad. I expected worse, actually. This question is definitely, again, on a test. So a lot of you said that you actually prefer doing it this way. It's 2 times negative 2m plus 1 plus 2 times 3a plus 2 and just plus 5k. So we can use, to make our expression shorter, we definitely have to use the distributive property, okay? Then see if we combine any terms because we want a simplified version. So negative 2 times negative 2m is negative 4m plus 2 plus 6a plus 4 plus 5k. I can simplify two things. This 2, so it's negative 4m. Doesn't simplify with anyone, but I can simplify the 2. I'll actually combine the 2 and the 4. So I'm just going to write negative 4m first, plus 6a, plus 5k, and then I'm going to put my two constants at the end. It's 2 plus 4 is 6. So that's right there's 1 point. The next thing we're going to do is replace. So I can replace whatever values the letters have. So m is negative 3, k is 7, and a equals 5. So negative 4 times m, which is negative 3, plus 6 times a, which is, let's say, 6 times 5, plus 5 times k, and k is 7, equals 6. So I replaced all my variables with values. Negative 4 times negative 3 is negative 12. 6 times 5 is 30, plus 30. I'm sorry, not negative 12, plus 12. And then 5 times 7 is 35. And then plus 6, I don't know what I wrote, equals 6. So now, I mean, seriously, this can't be any easier. You can just add them in the calculator, and you get 35, 40, 101, 113, I'm going to say. And that's your other point. So 1 point for giving this expression right here simplified, where I can't combine any more like terms. And then the other point for replacing it and finding a value for that expression. Okay. This one is likewise the same thing. So I get 2 times negative 3c plus 8 plus 4 times 2 because there's 4 of those sides. Apply the distributive property. 2 times negative 3c is negative 6c plus 2 times 8, which is 16, and then 4 times 2, they're both positive, so it just gives me 8b. There's absolutely nothing to simplify, to combine, because everybody is different. Now I substitute. For b is 4, c equals negative 3. So it's negative 6 times c, which is negative 3, plus 16, plus 8 times b, which is 4. Negative times negative is 18. 6 times 3, plus 16, plus 8 times 4 is 32. Now you just add. So it's, no idea, 50, 66. Yeah? 32 plus 18 is 50, then plus 16 is 66. So hopefully I'm correct. So, is there more? Yes. So for the following equation, w divided by 5 minus 10 equals 25, I want you to describe in words only, the steps you would take to solve the equation. So this is how I would do it. Number 1, I would use inverse operation of addition to subtract, to add I already messed up. So inverse operation of subtraction, okay, to add 10 to both sides, right? Because we're adding 10 to both sides, right? Then number 2, I would add, right? I would add those numbers, add 10 to both sides. That would result in, that would result in w over 5 equals 35, right? That's what I have if I added 10 to both sides. This 10s would cancel, and 25 plus 10 is 35. Step 3, I would multiply both sides by 5, right? Remember, w is being divided by 5. The opposite of the inverse operation here is multiplication, right? Opposite of division is multiplication. So I multiply that side by 5 and the other side by 5. I would multiply both sides by 5, resulting in w equals, So if I multiply this side by 5, both w's would cancel out, giving me 1w. And then on the other side, 35 times 5 is going to give me w equals 175, resulting in w. That's supposed to be a w. And resulting in w equals 175. It's pretty much what I'd like you to write. Now, was that simple? Last one, solve graph check. Sam Cameron. Inequality. Cameron goes to the pharmacy. He's going to buy rolls of toilet paper. Yay. That cost $1.29 each and one bottle of shampoo for $7.89. Cameron can only spend up to 20. Write and solve an inequality to determine how many rolls of toilet paper he can buy. So here's my one clue. $1.29 each. So right there is, I know, my variable. My variable with its coefficient, 129, and my constant is going to be 79. So it's going to be, so if I rolls of toilet paper, I don't know how many, so I'm just making a bunch here. Okay. I don't know how many. Plus one bottle of shampoo. So, and that all has to be up to, he only has up to $20. So all that has to be less or equal to 20. That would be my visual, sort of, if I had to. So I know the shampoo, I can change that to $7.89. There's actually a value to that. And the toilet paper, I actually don't know. Well, I don't know how many, but I know its price. So it's $1.29 times however many I buy. Plus $7.89 has to be less or equal to 20. So that's my inequality. And just because I'm gonna take the multiplication sign because I don't need it. So minus $7.89 on this side, $7.89 on this side, minus. Let me just write it over here. So these two will cross out. I'm left with 1.29p less or equal to 12.11. I'll divide both sides by 129. Right, so I hopefully understand that makes sense, right? Because I had $20 and I subtract the bottle of shampoo, I'm left with $12.11. And $12.11, I'm going to now divide by the price of the toilet paper to see how many I can buy. And it says that I can buy 9.39, rounded, okay, because it goes on forever and ever. So number of toilet papers that I can buy has to be less than 9, because then I can't buy part of a toilet paper roll. So that's one thing. When you graph, it's going to be 9, 10, 8, shaded. Number of toilet papers that I can buy, 9. And so this would be the whole thing that I want you to watch. The visual, not necessary, just using it. So hopefully some of you might, if some of you might need a visual, you can use it or create your own. Okay. And I think part 2 is done. That was so much easier than part 1. Okay, so let me put this up.